Well, hello YouTube, and today we'll be discussing ESXi logs. I'm vFanatic, and this is one in a series of videos in which I will be discussing more about virtualization, VMware, cloud computing, hardware, and anything that's related with virtualization. So let's get started here. Now, in any operating system, there are three different levels of logging. One is the OS related logging, which happens. The other is the apps, and the third is the data. Now, in this case, the OS would be the ESXi system level logs. The apps would be the apps that you run on top of the default hypervisor, and then the data can either be the user system VMs which are running on the hypervisor, or it could be a third-party app or any other app which writes data or interacts with the hypervisor, base hypervisor itself. So in order to figure out as to what's going on, each of these entities need to write the log files so that the logs, so that the user as well as the system gets to know as to what exactly is going on in the background. Now, generally, in any operating system, the logs are divided into these many items. So, at the top, you have the info level logs. Now, the info level logs are the logs written periodically when the system is running in its normal course of operations. So, any kind of an operation the hypervisor needs to do would be written in the info logs. Now, warning and error state events are written when there is something which actually is going against the normal working of the operating system. It can be a hardware issue, it can be a software issue, it can be a user error, it can be anything else that's there. But essentially, if you get a warning, that means it's non-fatal generally. So the system can recover, can continue functioning. But if it's an error, generally it's a hard stop. So error and errors can actually cause an application to crash. So errors are one step ahead from the warnings. Now, on a different subclass altogether are events. Now, events are either user-related events. For example, if a user interacts with any operating system, powers on a virtual machine, powers off a virtual machine, does a storage vmigration, does a vmotion, anything of that sort. So those are classified as events, and even those need to be traced, and that needs to be documented as well. So we'll get to how events are tracked later on, but then overall the info, error, warning, and events are what is captured normally during the course of the ESXi operation. Now, on an ESXi system, the logs are further subdivided into hardware, OS, VM, and user. Now, hardware events are events which are written in the IPMI system logs, or it's written in the boot.gz. And it can also be traced by using, for example, if you're running an issue wherein the system refuses to boot and it gets to a piece or something, then you can actually enable serial line logging as well. So hardware logs are written in multiple places, but then the most generic places you'll be able to find them are the boot.gz, the serial line logging, which you can enable, the IPMI system logs, and also the vmkernel and the VOBD logs. So we'll get to those later. Now, also the ESXi, essentially it's an operating system, so it needs to write data as to what's happening in the background as well. So the OS system logs are written in a variety of places, but most of the logging is actually within this var/log and the var/run./log. Virtual machine logging again can be either the hostd.log, or it can be within the vmare.log within the VM folder. We'll get to those later. User generated events also create log files. For example, if a user tries to do a vmotion and that's failed, that needs to be logged, that needs to be tracked as well. So these are overall the kind of logging that the ESXi does. Coming to the ESXi log location, there are two log locations which ESXi by default logs into. So one is the var/var/log, The /var/log is the in-memory logs of the ESXi. So those logs tend to get lost if you do a system reboot, and those are the in-memory logs. But then the var/var/run/log, once you go to the /var/run/log, that redirects you to the scratch partition. Now the scratch partition for long-time ESXi users is a persistent logging, which it's a persistent partition on the ESXi subsystem on which logs are actually written. Now the benefits of using a scratch partition is that the scratch partition is persistent across reboots. So what that means in simple terms is, if you take an ESXi system and if you write data, or rather logs in this case, onto the scratch partition, and either the OS crashes or you need to do a cold or a warm reboot, you'll find that the contents of the /var/log, which are the in-memory logs, do get overwritten, but then the logs in the var run log, they are persistent. So you'll find older logs which are rolled over and newer log files are generated, but then the older log files are always present. Now the boot logs and hardware logs, there are essentially two places where you can find them. One is after the system has booted, you'll find a particular file called boot.gz, which you can unzip, or you can use zcat to read the contents. And the other thing you can do is you can enable serial line logging during the system boot event, and that will capture logs for you on an external monitor or screen or a system. Now system logs are the logs which are written in the var log or the var run log folder, and generally those are the vmkernel, the hostd, the vmk. Coming to the actual log files which the ESXi has, so if you go into the /var/log or the /var/run/log folders, you'll see that there are a couple of log files which are generated. Now depending upon the service which is doing the write operation, you'll find that each of these log files has a particular name, and each of these log files are dedicated to a particular process which is running on the ESXi. So you have the auth.log, which logs the ESXi shell authentication success and failure, the dhclient.log, which is the DHCP client service including discovery, address lease request, and renewal. So essentially, if you're connected to DHCP server, if your ESXi is getting its IP address from a DHCP server, that's where the log entries for that are. ESXupdate.log, as the name suggests, is the logging for the ESX update process. So either if you do it by the command line or you do it through the update manager, this is the place to come and check if there are any passes or failures, which you might need to dig a little deeper. LSCP, link aggregation protocol logs, hostd.log. Now this is one of the more important logs which are present, that writes the host management service logs, including virtual machine and host task and events, communication with a vSphere client and vCenter VPXA agent, and SDK connection. We'll get to all of this later in a later video wherein we'll do a live demo. So here all we need to remember is the hostd.log is more concerned about the host management services, including virtual machine operation. Now hostd.probe.log, this is a log which this is actually a job which runs in the background, and it probes whether the hostd service itself is running or not. So if you have a hostd service which is failing, you need to probably come down and check this log to figure out as to what's going on in the background. Now the rhttp proxy.log, HTTP connection proxied on behalf of the ESXi host web services. We'll see that later. Shell.log, ESXi shell usage logs, including enable, disable, and every command entered. So essentially what it means is, if you're logged into the command line, if you're logged into CLI or PuTTY or any other SSH client, and you run CLI commands, so all of your commands which you enter are saved in the shell.log. So if later on, if you want to retrace what all commands you've run, that's a place to go to. sysboot.log, that's the early VM kernel startup and module loading. So What that means is during the early boot process, before the VM kernel or the hostd kicks in, this is the log file which will have most of the boot details. So apart from that, you have the boot.gz. So that's like the dmesg file in your typical Linux install, and that consists of the boot process, the hardware configuration, and the hardware discovery, the modules, the drivers which need to load. Everything is captured in the boot.gz. syslog.log, management service initialization, watchdog, schedule task, and DCUI use. usb.log, USB device arbitration events such as discovery and pass through to virtual machines. vobd.log. Now the vobd.log is a VM kernel observation event similar to vob component.event. We'll get to that later. So essentially, if you disconnect a NIC card or anything of that sort which happens, those apart from the VM kernel log, you'll also be finding an entry in the vobd.log. vmkernel.log, now that's the core VM kernel log file. So the kernel in case of ESXi is called the VM kernel, and that's the logging which that's the log file which it writes into. So core VM kernel logs including service discovery, storage and networking device and driver events, and virtual machine startup. The vmk now it's a curated feed of warning and alert messages which are taken from the VM kernel log. So the VM kernel log, whatever errors and warnings and alerts are there, that's actually that's passed from there, and it's created or written into the vmk warning.log. The vmksummary.log, now this is a particular log file which is important, a summary of ESXi host startup and shutdown, and an hourly heartbeat with uptime, number of virtual machines running, service resource consumption. So if you have an ESXi host which has kind of just booted or crashed, and you want to figure out as to what the last uptime was, how many virtual machines were running, what the memory consumption was, this is the log file that you need to check. exog.log, that's video acceleration. Now accessing the ESXi logs. Now in general there are three different methods that you can employ to check as to what's happening on the ESXi system itself and check the logs. The most familiar concept is the direct console user interface, or the DCUI. So what it entails is you can either do it through the console, or you can do it by, let's say, connecting a physical monitor and a keyboard, etc., to the ESXi host and just checking what pops up on screen. So once you log into the DCUI, you have an option of going down to troubleshooting options and enabling SSH and your ESXi shell, and that's another thing you can do. But then more importantly, what you can do is you can actually scroll down to system events, and you can check the running ESXi, hostd, VM kernel, vpxa logs. That's something you can do. Now once you enable ESXi shell and once you enable the SSH, you can also connect directly to either the single user console by using Alt F2, and you can enter the username and password. The username is root, password will be the default root password, and that gives you a single user command line interface by which you can manually go down to var log or var run log and check the logs. The other thing you can do is you can fire up a PuTTY session or any other SSH client for that matter, and once you enable the SSH and the single user shell, the other thing you can do is you can actually log in by using the SSH client. Even that's something you can do. Now SSH, it's generally you can use any SSH client, and you should be able to log in once you've enabled SSH on the DCUI. From the GUI, it's possible to check the system logs in two ways. One is if you're connected to the ESXi host by using the vSphere client, then you can go down to the log option on the vSphere client itself and check the logs. The other thing you can do is you can open a web browser and you can go to localhost/web, and even that's an option you can try out to check the running system logs. The other thing you can do is if your host is connected to the virtual center machine, then the other option you can have is just connect directly to virtual center and browse down, and you can check the log that way. Another option for accessing the ESXi log is just by capturing a log bundle. So again, that can be done in multiple ways. You can run the vm-support command at the command line and generate a log that way. So if you generate a VM support bundle, you'll need to use WinSAP or something to get to the log, and then download the log to your local system, and then just use a WinZip or something to unzip the log, and then you can browse by using the text browser. So that's something you can do. The other thing you can do is if you just connect by using the vSphere client, either through the virtual center. So the virtual center gives you an option of generating the log file. If you go to File, Export, System Logs, it basically just allows you to do it from the GUI itself. So you can generate a system log file that way, download it to your local machine. That way you don't need to actually rely on WinSCP. You can download the log bundle on the fly itself, and from there on the process is the same. You need to unzip it, untar it, and then you can check the logs and see what's going on. So even that's a possibility. So in short, if I could just recap what we have done. We've talked about the ESXi logs which are present. We've talked about the different type of logging which are enabled on the ESXi system. We've talked about the hardware logs, the VM logs, the OS logs, and the user events which are there. We've talked about the two locations where the log files are in case you need to check the logs on the fly. We've also spoken about the methods in which you can go ahead and get to those logs. So we've talked about the DCUY options, we've talked about SSH, and we've talked about the GUI options. So that brings us to a close of the log slides that we have on ESX. So as always, subscribe, share, and comment. And in the comment, if you can leave details as to what are the next videos that you want us to make, we can actually get those made for you. Thank you for watching.